All right, in this video, we're going to start talking about the difference between like speed and velocity. All right. Um, the first thing we're going to talk about is scalars, and scalars are quantities with only magnitude. Okay, magnitude means the size of it, and direction is not important. Okay, so examples of that are going to be like time or mass. Okay, like the mass of something might be 2 kilograms. You don't say 2 kilograms north. That doesn't make sense. It doesn't have a direction to it. And distance, and so on. All right. A vector is a quantity with both magnitude and direction. All right. And examples of that, these are quantities where direction is important. And one of them is going to be, say, velocity. Okay. In another unit, we're going to talk about force, which is a push or a pull. And it depends. The direction matters. If you're pushed north, you're going to move north. If you're pushed east, you're going to move east. So the direction is important for force. So it's going to be a vector. And magnitude just means the size of something. So if I have a velocity of 80 miles an hour north, the magnitude of it is just 80 miles an hour. It's just how big it is without the direction. So distance is how far total without direction. So it is a scalar, and our letter for it is going to be delta x. Displacement is going to be a little bit different now. This is going to be your position relative to your starting point. And it is a vector. Because if I say I'm 8 meters from my starting point, you don't know where I am. Okay? But if I say I'm 8 meters due north of my starting point, then you would know exactly where I am. Okay? And we use delta x for that as well. Speed is how fast, and it's the scalar version, so there is no direction. And when we calculate average speed, we're going to use delta x over delta t, like from last unit. But in this case, the delta x has to be the distance. And this is going to be average speed over here. All right. And then our last definition is going to be velocity. This is how fast, but it's a vector. It has direction. We're going to use the same equation, but this time for delta x, we're going to use displacement. And this is going to be average velocity. All right. So some examples. And it helps a lot to draw little sketches for these. So I got a cat. It's going to walk 12 meters east. So I'll draw my little cat. Okay, there's my little cat. All right, he's going to go 12 meters east in 6 seconds. And then he's going to turn and he's going to run back 36 meters in 3 seconds. All right. And part A, we want the distance. Well, we don't worry about directions. He just went 12 meters and then 36 meters. So the distance delta x is going to equal 36 plus 12 is 48 meters. Okay, now B, we want to know his displacement. His displacement is where he is relative to his starting point. So this is going to be his displacement. All right, so the displacement, delta x, in this case is going to be, he went 12 this way, but then back 36. This is going to be 24. So it's going to be 24 meters, and it has to have a direction to it. So he ended up 24 meters west of where he started. Part C, the average speed. When we find average speed, we're going to do delta x divided by delta t. But in this case, we want to use the distance. So we want to use 48. 48 meters in, it was 6 and 3, so 9 seconds. And that's going to give me a value of 5.3 repeating meters per second for his average speed. His average velocity, I'm going to use the same equation, but this time I'm going to use the displacement. So 24 meters west in 9 seconds, and divide that out, I'm going to get 2.6 repeating meters per second west for his average velocity. And then E, it wants the magnitude of the average velocity. That just means the size. Okay, so the size of it is this 2.6. So I can just say 2.6 repeating meters per second for the magnitude of the velocity. Okay. Next one's going to be a little trickier. Okay, but a sketch again is going to help. We have a boat that's going 30 miles per hour south. So that's its velocity. For 2 hours, that's a time. And then he's going to turn and go 50 miles per hour for 90 minutes. Okay, and I want to write down that 90 minutes is 1.5 hours. I want to convert that to hours. And then it says the displacement for each leg of the trip. So I could do delta x is v times t. So for this one, 30 times 2. So delta x for this guy is going to be 60 miles. And then over here for this one, delta x is going to be 50 times 1.5. Delta x is going to be 75 miles. So that was A. B, distance traveled. Distance is just how far he went altogether. I don't worry about directions. So delta x is going to be 60 plus 75. Delta x is 135 miles. Now C, displacement is how far he is from his starting point. So if we start here, or where he is relative to the starting point, he ends up here. This is going to be the displacement. We're going to call that delta x. Now, how am I going to find that? Well, I can just use the Pythagorean theorem. And you don't have to write this out in detail. I'm just writing that we're going to do the Pythagorean theorem so that you can see how we got the answer if you're looking back at it. But Pythagorean theorem says a squared plus b squared equals c squared. So 60 squared plus 75 squared is delta x squared. And again, I'm not going to show all the steps. You can if you want to, but you don't have to if you don't want to either. But I'm going to square them and add them together and then take the square root. So 60 squared plus 75 squared equals, take the square root, and I get 96.0 miles. Okay, now if you take a look at what I have in my calculator here, I got 96.0468, all that. We don't have to worry about significant figures in physics. Okay, they don't care about it as much as they did in chemistry. So if I wrote 96, it'd be okay. If I wrote 96.05, that would be okay. If I write out all this stuff, that's okay too. All right. Now, I also have to tell, so that's the magnitude of the displacement. How big is it? But I also want to know the direction. So for part D, I'll put that over here. I'm going to redraw this a little bit. Okay, so I went down this way, 60, then over this way, 75. And I want to tell somebody who is here how to get to that point. I can tell him he's got to go 96, okay, but I have to tell him what direction to go. So what you do is you draw in an east-west line, because I want to make all my directions relative to east and west. So I'm going to find this angle right here. Okay, so I can kind of make a triangle up here. This side of the triangle is 75, and this side of the triangle is 60. And I have to find that angle. And we're going to have to do some trig. And your trig might be a little weak, but as you practice, it'll get better and better. But if this is the angle I want, I have this side is the opposite, and this side is the adjacent. Adjacent means next to. Okay, opposite means across from it. This side over here is a hypotenuse. And then I can write out like SOHCAHTOA, however you remember your trig functions. You don't have to show this if you don't want to. Okay, I'm doing it to show you the details of how I got there. Okay, but I have the opposite and the adjacent. Opposite and adjacent is tangent. So I'm going to use the definition of tangent. Tangent of the angle is opposite over adjacent. Again, you don't have to show this step. This step you do need to show. Okay, and it's 60 divided by 75. So this step, I'll put a little star. That one you have to show, all right, if you want to get full credit on the problem. This step you don't have to show, but you can if you want. 60 divided by 75 is 0.8. How do we get rid of tangent? I can't divide by the letters tan. The opposite of tangent is tan minus 1. So theta is going to be tan minus 1 of 0.8. And then my answer, if I type that into the calculator, is going to be 38.7 degrees. Okay. So the two things with stars, that's what you have to show. You have to show that you're using tangent, and you have to show the answer. And I have to describe it. So my reference line is west, and the boat swung south of it. So I'm going to say south of west. I can't say southwest because southwest west means exactly halfway between south and west. And this one's more west than it is south. So I have to give an angle and write south of west. All right, E. Okay, what is the average speed of the boat? So for average speed, I'm going to do delta x over delta t. But I have to do distance on top. So my distance back here was 135. So 135 miles over, and my time is 2 hours plus 1.5 hours is 3.5 hours. And when I calculate that out, I get 38.6 miles per hour. So I did that part there. And then part F, I want to know the magnitude and direction of the average velocity. So average velocity, I use delta x over delta t again, but this time I want to use the displacement, which was 96 at an angle of 38.7. So 96.0 miles at 38.7 degrees south of west. And I'm going to divide that by the 3.5 hours. And I get the average velocity is, if I put that in my calculator, 27.4 miles per hour at 38.7 degrees south of west.